Dear aspirants, welcome to my channel. This is an model question paper 3, concepts of mechanical engineering, remaining 10 marks questions. So already 2 questions I uploaded. So remaining 3 questions I am going to upload this video. So which press operation is the best for mass producing washers, and explain the process with a reason. There's a two best method is called blanking and piercing. Coming to the an introduction, so what is a washer? The washers is a circular components with a central hole. So which we can use it for how you are going to produce. It is a mass production and press working operation. We can use press working operations which we can use, and the best method we call it as a blanking and piercing is the most suitable combination. The coming to the suitable operations. So what do you mean by blanking? So in the blanking, what you have to do? You have to produce a outer circular shape of the material, but pricing we are producing inner hole. So coming to the process of explanation by step, one is in sheet feeding. First method we have to go for sheet feeding. In this sheet feeding, here we are using a metal strip. You have to give to feed and press the machine automatically. Okay. And next process is the blanking operation. In this blanking operation, so we have to punch and die, cut the outer diameter. You have to make a hole and remove the whatever pieces will be there. You can remove the pieces and become the washers. You have to make a hole, and whatever pieces you are going to remove, that we call it as an wash. Step 3, piercing operation. In this piercing operation, a small punch, you have to create an inner hole. Whatever scrap material will be there, that you have to remove from the center. Once you are done the operation, you have to remove material. Next we call it as ejection. In this ejection, we have to finish the washers and eject from the die. Next will be an continuous production. In this the progress will be continued. Blanking and piercing, you can occur a single stroke at the different stages. Okay, and which will be an high speed and continuous production. So coming to the reason why we have to select it, the reason why we have selected, it will give high production rate. It means it will be ideal mass production will be more. Dimensionally accuracy and uniform, it should be accurate and dimension uniform, and smooth edge with a proper die clearance. Smooth edge which are proper. It is an economical process, means which if it is an economic means cost, based on cost we have to determine low cost, and less material wastage we can use for less material wastage. A proper steps layout you can make it, and automation is possible, the progression with the dice. And next will be, we can highly repeatability and consistency, you can repeat more the times. Coming to the applications, we can use it for washers, we can use for bolt joints, automotive parts, and machinery assemblies, there we can use. Next question is fourth question, explain the nomenclature single point cutting tool with their significance operations. So in this, what is this nomenclature natural single point cutting tool? What it means? It is a single point cutting tool which we can only use it for cutting edge, use it for the lathe operations. So coming to the parts and angles, it consisting of shank. Shank is a main body of the tool, and it is holding tool holder, and it provide rigid and support. Coming to the next part is a face. Face is a top surface on which chips flow, and it affects chips movement and heat dissipation, which we can use that. Next will be in flank. Flank which is a surface where you are going to, it is a surface below the cutting edge. Why we have to provide, it will give a clearance to avoid the rubbing. Next will be an cutting edge. It will use for edging, remove material. It is a side cutting edge, and next one is a end cutting edge. Next is an tool tip. So this we can use it for, it is intersecting the side and end cutting of the cutting edges. It have as a nose radius and improve the surface finish. Next will be an rack angle. It is an angle with respect to an horizontal. It is having a two types. One is a positive and negative rack. Okay, it helps to chip flow and reduce the cutting force. Next will be in clearance angle, also we call it as a relief angle. This angle it between flank and work surfaces, which prevent the tool rubbing against the work pieces. Next will be a cutting edge angle. It is having two types of angle. It is side cutting edge angle, end cutting edge angle. Side cutting edge angle which will control the chip flow direction. Coming to the edge cutting angle which will be prevent tool rubbing. Next is nose radius. In the nose radius, it is a small round tip at the cutting point and improve the surface finish and tool life of the material. Coming to the significance of lathe operation. So it is having a efficient cutting. It means it will give a proper rank angle to reduce the cutting force, and it is a good surface finish, means the nose radius improves the finishing and tool life. If you give a correct angle, reduce the wear and tear, wear and heat, and chip removal. It is a proper design to ensure the small chip flow. If it is an accuracy, you have to properly geometrical maintenance dimension should be an accurate. Reduce the friction, we have to give a proper clearance angle to prevent the rubbing. Less power consumption is sharp tools. If you use energy is not that much, it is required. It is reduce the energy requirements. Next question is describes the classification of the milling machine. Which milling machine type is preferred for a machining a large work pieces and why? So coming to the classification, which we can classify based on a design and application. The first one is a column and knee type of the milling machine. This type machines we can use it for commonly we can used, and which is having a vertical col and adjustable knee. There's a different types of column knee type. One is an horizontal milling machine and vertical milling machine. And one more is a universal milling machine. Next will be fixed bed or manufacturing type. So it is like a table fixed. Name only fixed means table fixed, only spindle moves, and it is a heavy and rigid constructions we can use, and it is used for mass productions. Next is a planar type milling machine. This which we can use it for planar, similar planar machines. So where we are to use it is having a table muse and multiple cutters can be used. It is suitable for large and heavy work pieces which we can use it for planar type of milling. Next will be a special purpose milling machine. It is a design for specific operations like a rotating table milling machine, drum milling machine and profile milling machine. Next will be an CNC milling machine. It is a computer controlled machine. It is having high accuracy and automation, used for complex shapes and precious parts. So usually which type of milling machine which we can use prefer for machine large work pieces? We are recommend a planar type of milling machine. Coming to the reason why we are selected planar type of milling machine. The reason behind it is handling large and heavy work pieces. It provide a rigid construction for stability. Table can carry heavy loads. This we can carry heavy loads, and it is used for multiple cutters to operation simultaneously. It will give a high productivity and accuracy, and suitable for large flat surface and long components, which you can use planar type of milling machine. If the content is useful, please subscribe my channel, share and support. Keep watching until end of the video. Thank you.